In the previous chapter, we learned how to create, read, update, and delete records using a single model and a single database table. But what if we wanted to work with the data in related tables? That's kind of the point of a relational database after all. We could go about it by querying for a record, reading the value of its foreign key, and then finding the related record by making a second query with the foreign key in the query conditions. That would be a valid approach, but it is tedious to write out all that code every time we want to find a related record. It would be better if we could define the relationships between our models, and therefore between our tables, and then work with those relationships in an object-oriented way, and let Rails do all the behind-the-scenes work for us. Active Record provides something called associations that allow us to define these relationships. We'll start out by looking at the general types of database relationships, and then learn how Rails handles each one. There are three main relational database types: one-to-one, one-to-many, and many-to-many. To help you to visualize each one, let's use a concrete example. Imagine a school. Each classroom in the school is assigned a teacher. The teachers don't change classrooms, and they teach 4 classes per day. The students change classrooms throughout the day as they move from course to course. Okay, you have that example in your head? An example of a one-to-one relationship would be the relationship between the classroom and the teacher. A classroom has one teacher. A teacher is assigned to the classroom. In this case, the foreign key goes on the teacher's table. If we wanted to diagram it, it might look something like this. We've got the parent, which is the classroom, room 107, and then the teacher, Martha Cook, which is the child record. So if we wanted to find out what classroom Martha Cook is in, we would look at the ID stored in that table, and then query the classroom's table for something with a matching ID. If we had a classroom and we wanted to find the related teacher, then we would query the teacher's table for a classroom ID that matched the current ID. Some of you might be wondering why we couldn't define this the other way around. Why couldn't we assign the classroom to the teacher? You could. It is a design choice that you make. In that case, the foreign key would need to go on the classrooms table. Then each teacher would have one classroom, and each classroom would belong to a teacher. To me, it makes more sense for the room to have a teacher instead of the other way around. The key point is that one of these two items has to have a foreign key, and it's going to go on the one that belongs to the other one. That one is the child record, and that's where the foreign key always goes, on the belongs to side of the equation. The second relationship type that we have is one-to-many. An example of that would be how a teacher has many courses. We could also say that a course belongs to a teacher. In this case, the foreign key goes on the courses table. If we diagrammed it, it might look something like this. Martha Cook would be the parent record, algebra, geometry, physics, and programming would be the child records. Each one of them would contain a foreign key. They would each have the ID for Martha Cook, so that we would know that algebra was assigned to Martha Cook, that geometry was assigned to Martha Cook, and so on. In this case, it is not a design choice as to which direction they go. You can't flip it around. If the foreign key was on Martha Cook, we would store algebra's ID there, but then what would we do with geometry's ID to make that relationship? We have to store the relationship on the belongs to side of the equation. The third relationship type is many-to-many. An example of this would be how a course has many students. Of course, at the same time, a student has many courses. That's why it's many-to-many. We have many courses and many students, and they're all interrelated. In this case, we're going to have 2 foreign keys, so they're going to go in a join table. A join table is going to be a third table that's going to sit in between our 2 existing tables in order to make the relationships between them. Let me show you an example. Let's say that I have 4 courses: chemistry, geometry, physics, and programming. And I have 4 students: Michael, Jennifer, Jason, and Amy. So let's say that Michael is taking chemistry, geometry, and physics. Now there's a problem if we tried to put Michael's foreign key on the course. What would happen then if Jennifer was also supposed to be taking chemistry? Where would her foreign key go? We could perhaps add another foreign key column onto the courses table to hold that second relationship, but we have many students who could be in there. If there were 100 students, would we have 100 columns for foreign keys? No, we wouldn't. A much better solution is to use a join table. That's a table that sits in the middle and simply holds the 2 foreign keys. So we now have an entry that holds the relationship between chemistry and Michael, and it has those 2 IDs. So if we want to know what courses Michael's taking, well then we take Michael's ID and we consult the join table. And we say, join table, give me all the entries that have Michael's ID, And then we can look at the course IDs that are listed on the other half of the join table as the other foreign key, and then look up those courses in the courses table. If you haven't worked with join tables before, or if this concept isn't clear to you, it might be worth pausing the movie here just to think about it a little more and make sure that the idea is solid in your head before you move on. Now we've seen the three main relationship types. It's no accident that I put quotes around has one and has many, because Rails will use those same terms as method names. So for one-to-one, we say that a classroom has _1 teacher. Classroom has one teacher. And then the reverse of that would be that the teacher belongs to the classroom. When we're working with a one-to-many relationship, we would say that a teacher has many courses. And on the course side, we would say that a course belongs to a teacher. You can see how those correspond to the database relationships. When we're working with many-to-many, we're going to have both courses and students that have many and belong to many. So the Rails method name is going to be has and belongs to many. It's a very long name. Often when people are just discussing it informally, they refer to it as an HABTM method. So HABTM, if you ever see that, is the shorthand for this, but you can't use that in your code. You actually have to write it out. Course has and belongs to many students. Student has and belongs to many courses. Now notice that the pluralization is important there. So when we were talking about the has one relationship, it's going to be singular on the other side of the relationship, that a classroom has one teacher, singular, but in this case, course has and belongs to many students, plural. Now as a footnote, has and belongs to many is how we're going to create a join table when the table is simple and it uses only foreign keys. A little later, we'll talk about how to do a more complex many-to-many association. Okay, now that we have an overview of how each one works, let's go a little deeper into each one.